Hey there, welcome back to AeroSafe. Today is March 24th, 15:15 Zulu, or 11:15 Eastern. We'll be using the AeroSafe Weather Brief Checklist to look at the weather today. If you want access to the Weather Brief Checklist, you can go to gilbertaviation.com. If you're catching this after March 24th, don't worry, there's still a lot of value in walking through one of these weather briefings with me. We'll be looking at current conditions, but on top of that, we'll be talking about how we can look at weather, understand what's going on, and make good, sound aeronautical decisions as general aviation pilots. I'll be using 1-800-weatherbrief.com to do a majority of this weather briefing. And if you look at the page here, this is what the home looks like after you log in. And then I like to go to the weather charts page. We'll start with the surface analysis. As pilots, we look at the surface analysis to get an idea of the frontal and pressure systems that exist across the U.S. This gives us a good indication of the kind of weather that we could anticipate or expect along our route of flight, or that may move in to our route of flight. Over eastern Canada, we see a couple of high pressure systems. That high pressure kind of persists all the way down through Florida. Probably the biggest story on the surface analysis today is the low pressure systems that exist over Wyoming, Colorado, and New Mexico. From those, we see extending quite a few different frontal systems. So a cold front to the east, and then down to the south of that, we see a warm frontalysis and a cold frontalysis. Frontalysis is a front that is weakening in strength. Practically speaking, what that means is we could still expect some of the weather associated with a warm front or a cold front, but we know that those two air masses are mixing and the weather is going to be dissipating and typically improving. Over northwestern New Mexico, there is a low pressure system with a cold front extending to the south, and if we move farther south over towards the Baja Peninsula, a cold frontalysis. Again, a weakening cold front. Wyoming's low pressure system can be traced to a low pressure system over Washington by a stationary front. Not a whole lot of troughs today, which are areas of elongated low pressure. We see one going from Wyoming up into Montana, one kind of over the coast of Washington and Oregon, and then a tiny one connecting a couple of low pressures over Colorado and New Mexico. Now get ready to pause the video because here is a check ride question. Over Colorado stretching down towards western Texas, what is indicated by that yellow line with the semicircles? Why does it matter to us as pilots? That indication, the yellow line with semicircles, depicts what's called the dry line. It shows the boundary between moist air and dry air. That moist air comes up from over the Gulf of Mexico, and the dry air comes from the desert over New Mexico and Arizona and Nevada. What matters to us as pilots is that there can be strong thunderstorms as a result of that boundary between moist and dry air. The dry air is more dense, so it would, if progressing, push up the moist air, which of course is one of the ingredients that we know is required for thunderstorms: lifting action. Now, we typically don't see as strong of thunderstorms as exist with, say, a cold front, but it is important to know that the potential exists. So that's the surface analysis. We've got high pressure on the East Coast, we've got low pressure in the Southwest, and some frontal systems that extend from those. Let's look now at the interactive map on 1-800-WEATHER-BRIEF. All right, looking at flight category along the East Coast, as could be reasonably expected, we see a lot of VFR. Not only do we see VFR categorical reports, we also see green stations that have a hole in the center, which means there's no ceiling and no clouds at all. Hazard, Kentucky, has no wind, 10 miles of visibility, and clear. Where we see a little bit of opposition to that trend is in Florida, Central Florida in particular. We see a lot of blue station reports, which of course is marginal VFR, a ceiling between 1,000 and 3,000 feet AGL, or visibility between 3 miles and 5 miles. Only one of those criteria needs to be met to fall within marginal VFR. If we look at Leesburg, Florida, wind is 030, 14 gust to 7, 10 miles of visibility, broken at 2,000, overcast at 2,500. So Central Florida is currently, I would say you'd want to be on an instrument flight plan to be flying down there. And then also you'd want to be sure that surface winds are within your personal minimums. Gusting to 27 knots is quite strong, especially depending on the orientation of the runway and what portion of that 27 knots is going to be crosswind component. However, if we look a little bit more in depth here at Leesburg, it does look like weather's going to be improving. Wind will decrease in strength to 12 knots, and the ceiling's going to dissipate. East Coast looks like VFR except for Central Florida. If we move up into the Midwest, we start seeing fewer reports of VFR as a flight category. Over Nebraska, there are lots of low IFR, so ceilings less than 500 or visibility less than 1 mile. So at Norfolk Regional in Nebraska, we've got a special observation. Visibility is 1.5 miles, and it's overcast at 400, and it's going to get worse. Here's another check ride question. What does this mean here? OVC 060CB, Charlie Bravo. Why does it matter for pilots? In this time period of the TAF, there's a prediction, a forecast of wind being 150 at 16, gusting 25, 3 miles of visibility, thunderstorms and rain, overcast at 600, cumulonimbus. Not only is that a very low ceiling, it is also a thunderstorm. Now, of course, we know that we can't fly through thunderstorms, and we don't even want to be near thunderstorms. The traditional standard set by the FAA is that we fly at least 20 miles away from thunderstorms. However, I was recently talking to one of the meteorologists at the Louisville Regional Office of the National Weather Service. He thinks it might be more appropriate to be 10 miles away for every 10,000 feet of vertical development. So the bigger the thunderstorm is, the farther away we want to be from it. The reason is the larger the thunderstorm, the greater the hazards are associated with that thunderstorm. I would not be flying around Nebraska today. And it looks like that is largely caused by this low pressure system and a lot of the weather associated with the frontal systems coming off of that low pressure. With the Midwest being IFR marginal or even low IFR, that's an area that I would stay away from, especially as we get into the air mets and look at where the freezing level is. Moving south, we do see some areas of marginal VFR over Kansas, Oklahoma, and the southern tip of Texas. Along the west coast, we see a mix of flight category as well. There are quite a few VFR stations. However, most of them are filled in, which indicates a ceiling. If we look at Caldwell here in Idaho, wind is 260 at 3, 10 miles of visibility, few clouds at 6,500, and overcast at 8,000. The TAF indicates some not so pleasant weather coming in. Very strong winds are anticipated here in Idaho later today. 12 knots gusting 22, 15 gusting 25, showers in the vicinity, and ceilings coming down. So with that being true, this is probably an area that I wouldn't want to be flying around just for fun, especially given that the weather around the area is so spotty. Southern California looks pretty good here. We got a lot of VFR categorical reports, some of which have a ceiling. Fresno, California, few at 1,000, broken at 3,700, overcast at 4,500. So while it looks good for now, we actually do see weather is anticipated to deteriorate. So if we look across the whole country, we've got VFR along the East Coast, except for Central Florida, which is anticipated to improve. And we've got some areas of VFR here and there, and largely the northern border with Canada, we've got IFR, and then the heart of the country, we've got IFR too, as associated with that low pressure system and the fronts that extend from it. Some of these areas that are categorically reporting VFR, I would want to look much more in depth to make a accurate go or no-go decision. As we'll see here in a second, I'm sure there are additional hazards associated with flying instrument conditions in those areas. So if we reference the AeroSafe weather brief checklist, we've done the surface analysis chart. Let's look now at Sigmets and Airmets. Alrighty, these white boxes indicate Sigmets, and the gray boxes with dashed outlines are outlooks. So we've got a convective Sigmet over northern Missouri, embedded thunderstorms moving at 25 knots, tops at 39,000. This Sigmet over northern Texas and Oklahoma, very similar. Embedded thunderstorms moving at 40 knots, tops to flight level 390. Over Arizona, New Mexico, a little bit smaller thunderstorms, doesn't make them any less hazardous for general aviation pilots. Embedded thunderstorms moving from 250 at 25 knots, tops at flight level 260. And we've got some convective outlooks as well, meaning that they're anticipating convective activity within those areas. So I definitely have a little pause in those areas before I went flying, and even around those areas. Let's turn Sigmets off and look at Airmets. We'll look at Airmet Zulus first. Airmet Zulus indicate freezing or icing conditions. Along that northern border of the U.S., we see those areas where, I said, hey, it's IFR, but you want to look at the hazards a little bit more in depth. And here we see Airmet Zulus up in the Midwest. Base at the surface tops at 19,000. So it's freezing on the surface. There's visible moisture very close to the ground. We know there's IFR, marginal VFR, and low IFR in this area. So pretty much as soon as you enter a cloud, you would anticipate accumulating some icing, which we don't do as general aviation pilots with no anti or de-icing structural capability. We got something similar up in the Northwest. Bases are between the freezing level and which is between the surface and 6,000 up to 16,000. So you're not going to be able to get above that. This one in the Southwest, freezing level between 5,000 and 9,000, tops at 19,000. I think the only icing airmet that you could reasonably fly under would be this one in Texas and Louisiana. So for the most part, we're seeing that those areas of IFR, you wouldn't want to fly IFR as a general aviation pilot because there's also icing conditions. There are Airmet Zulus out warning us that there's a high likelihood you'd accumulate icing. Okay, I just happened to turn on the layer with these center weather advisories, and a couple of them are reporting ice. This one here in Minnesota, area of occasional moderate mixed ice between 3,000 and 9,000. It's clear that you're not going to be able to stay out of icing conditions if you were flying there. This one in Nevada is for IFR conditions. Visibility as low as 1 statute mile. We'll turn on the Airmet Tangos, Tango or T for turbulence. We got a lot of pretty colors popping up along the East Coast and the southern part of the U.S. from California all the way to Florida. The green airmets are for high-level turbulence, which don't apply to us usually as general aviation pilots below flight level 180. While they don't necessarily apply to us, they can give us a good indication of the overall composition and stability of the atmosphere. We do have an Airmet Tango for low-level turbulence along the coastal region of the East Coast, moderate turbulence below 10,000 feet. In the central U.S., we see low-level wind shear and low-level turbulence. Those are going to be associated with all the convective activity that we see going on. Moderate turbulence below 9,000 and low-level wind shear throughout a good chunk of the heart of the U.S. Along the southwest, we also see some sustained surface winds. Down in Southern California, very strong winds greater than 30 knots and some low-level turbulence as well. Wyoming and Montana, we see another sustained surface winds greater than 30 knots. Buffalo, Wyoming, 340-24 gusting 36. That area is kind of nasty enough anyway with precipitation and the Airmet Zulu, so we wouldn't be flying there anyway. We'll turn on the Met Sieras, and those confirm a lot of what we've already looked at. Met Sieras are because you cannot see, so they're IFR conditions and mountain obscuration. Large area of IFR conditions in the Midwest. Mountain obscuration along the whole of the West. We've got Met Sieras, we've got Met Zulus, and we've got some Met Tangos as well. So it's not looking good for our friends up in the Midwest and West. Okay, we've looked at surface analysis charts, Sigmets, Mets, freezing levels. Let's look at PIREPs and then cloud coverage. PIREPs are really great because they are the only report that gives us actual information about what's going on in the sky. Mets and Sigmets are based on models. We can look at the PIREPs to really get a good indication of actual conditions right now. I'm seeing a lot of reports of ice, some reports of turbulence. I really wish there was a way to split this up between altitude, moderate rime, between 4,500 and 8,000. Looks like a GALX is a Gulf Stream. So if a Gulf Stream is reporting moderate rime icing, it's probably quite a bit more than your Cessna or Piper can handle. Overall, there's lots of PIREPs, and they support a lot of what we've already talked about, which is some turbulence and some icing. There's some important notes to make when you look at PIREPs. That is, what's the altitude of that aircraft, what type of aircraft is it, and what exactly are they reporting. So those three things together can help us make sound decisions. For the purposes of flight planning, you'd want to look at your route and any PIREPs that exist on or near your route of flight. Alrighty, now we're going to look at cloud coverage. If we go to the weather charts page on 1-800-Weather Brief, we can go down to the bottom right to cloud coverage. We can select our region. I'm going to do contiguous US for 3 hours from now. This shows us cloud bottoms, tops, and the sky coverage of the cloud layers. This really supports everything that we've already looked at. We've got a lot of IFR areas along the north and in the west. Where this chart could be super helpful is determining your cruise altitude, either as a VFR pilot or an IFR pilot. As a VFR pilot, you could look at this to figure out what might be a safe cruise altitude to be above terrain and obstacles and within your VFR cloud clearance requirements, which of course is at least 500 feet below. My personal minimum in VFR is at least 1,000 feet below. As an IFR pilot, you could look at it to see if your cruise altitude is going to be in IMC. Now, if you're hand flying, that can be super tiring for 2 or more hours at a time in IMC the whole way. One way you could use it is to see, is there cloud tops that are reasonable for me to get above, just to help relieve some of that fatigue that I could experience. This chart also gives us icing and mountain obscuration air mets, which of course is useful if we know we're going to be in the clouds or near terrain. Let's look at the visibility, surface winds, precipitation chart. There's a lot going on here. So we see some of the stuff that we've already looked at. We've got precipitation both in the form of rain and snow. We see thunderstorms. We see strong surface winds. Air mets for icing. This chart is helpful to understand what kind of conditions exist on the surface in terms of precipitation and visibility, wind, and any air mets that could be associated with those conditions. This chart is available in ForeFlight. What I've been seeing lately with candidates on their practical exam or their check ride is that because these charts are accessible on ForeFlight, an examiner can ask you to pull any one of them up and start asking you questions about the chart, what depictions mean, and how you might make decisions based on the information on that chart. I would encourage you to go through ForeFlight and get familiar with each chart and its depictions and how you can make decisions based off of that. If you're interested in some one-on-one consultation to help walk you through those charts and decision making, feel free to reach out to me on gilbertaviation.com. If not, you can just keep watching these videos and get the pieces put all together. All right, we've looked at surface analysis, Sigmets, Mets, PIREPs, cloud coverage, freezing level. So the last thing we're gonna look at here are the winds aloft. Winds aloft are super important because they affect our ground speed, which then affects our time en route, which of course affects our fuel burn. And then it can affect if we need to stop for fuel to maintain not only our legally required fuel reserves, but also our personal minimums for fuel reserves. Get ready to pause the screen because here's another check ride question. Based on the wind that we see over Montana and the Dakotas, Wyoming, and Nebraska, at 10,000 feet here, what kind of weather system would you expect exists in that area? First of all, let's look at it. What way is the wind blowing? So the flag shows the direction that it's coming from. So here in Canada, it's coming from the east. As we move down into Montana, western Montana, it's northerly. Over Colorado, it's westerly. Then over the Dakotas, it's a southerly wind. So that wind is moving in a counterclockwise fashion. If we go back to our surface analysis chart, we see that there is a low pressure system and a trough in that area. So the combination of those two are creating this counterclockwise rotation. We also see that there is high pressure over eastern Canada. So we would expect clockwise rotation there. And wouldn't you know it, that's what we've got. Here's another question. This wind here up in far northeast Kansas, this wind barb right here, what direction and velocity is indicated from that barb? We said just a second ago that the flag indicates the direction the wind is coming from. So with that being true, the wind looks to be about a southwest, maybe a 230, 220 or so. The actual flag on the wind barb indicates 50 knots of wind. And then we add to that half a barb, which shows 5 knots. So at 10,000 feet up here in northeast Kansas, they're saying winds from the southwest at 55 knots. We've already determined that there's quite a few hazards associated with flying in that area. There's convective activity, there's icing, there's high winds, obviously. But if there weren't hazards associated with the wind, you'd want to be very mindful with wind that strong if you had a tailwind or a headwind. At the speeds that a lot of light piston, general aviation aircraft go, that could be potentially half of your ground speed, maybe a third for some of those more fortunate, or a quarter of the speed, but that will highly affect your time en route and how much fuel that you burn. If we refer back to the AeroSafe weather brief checklist, we've now covered surface analysis charts, Sigmets, airmets, pyreps, cloud coverage, freezing levels, winds aloft, surface forecast, METARs and TAFs. And the last bit, if you are actually going on a flight, you'd want to call 1-800-WEATHER-BRIEF, talk to a weather briefer, get some more in-depth information. Thank you so much for tuning in to AeroSafe today. If you're interested in some swag, please drop a comment below. Let me know what you have learned about weather in the past month that may affect the way you make decisions in the future. I hope you have a great week, and we'll see you soon. Bye.